Hi everyone, this is the 32nd video of the ACT Math Practice Problem series, and here we have a nice little problem from the number concept and the concept of exponents. As I always recommend, before seeing the solution, you can pause the video and give it a try yourself, and after that of course you want to match with my solution. So let's get started. Here the question says that if A, B and C are distinct odd natural numbers, so A, B and C, they are all natural number meaning positive integers and they are odd numbers. Right? And D is an even natural number. So D is also a positive integer, but it's an even number. So let's make a quick note here that A, B, C are odd and D is even, right? That's the most important information here in this problem. And then the question says that what kind of value it would be the A minus B whole to the power C and then whole to the power D. You know, this quantity will be what type of value, whether it's going to be a positive and odd number, whether it's going to be a negative odd number, whether it's going to be a positive even number or negative even number or a non-negative even number, right? So as you can see, A minus B, both A and B are odd numbers. So the difference of two odd numbers is actually always an even number. This is something we need to understand very clearly. So if we say odd minus odd, right? So if I write an odd number, say for example, say 5 and minus 3, this turns out to be 2. If we say okay, 9 minus 5 maybe, that turns out to be 4. If we say, well, maybe let's take a bigger one, maybe say 31 minus 21 maybe, and that gives us 10. So as you can see, we always see that the difference of two odd numbers is always an even number. However, in this case, we have not been told whether A is greater than B or B is greater than A. So, you know, it could be, so if we simply say A minus B, that will be either a positive even or a negative even number. So can we write it like this? It could be either a positive even number or a negative even number. Now, if that is the case, then A minus B whole to the power C. So can we write A minus B whole to the power C? I'm just taking one step at a time, right? So A minus B whole to the power C, that is actually plus or minus an even number, positive or negative even number, whole to the power an odd number. C is an odd number. Now, because it is an odd number, the result will be either positive or negative depending on this even quantity, right? So this result will become positive or negative of an even number, because if you raise an even number to an odd power, for example, if I raise say 2 to an odd power, it's still an even number, right? Now if you raise a negative even number to an odd power, that again gives us an even number, but it's negative. It's still an even number even though it's negative, right? So no matter what power we use for an even number, we always get an even number. Now the sign will depend on the power, of course. If the sign is negative and the power is an even number, then it will become positive. If the sign is negative and the power is an odd number, then it will still give us a negative value, right? So in this case, we can write it as it will again become an even number, but it could be plus or minus, right? So this is still an even number. So now what would be A minus B whole to the power C and then whole to the power D? We also have a power D. D is an even number. So now this A minus B whole to the power C, this quantity right here, this quantity can be replaced with plus or minus even number, and then we have a power D or exponent D. D is an even number actually. In this case, D is an even number. So now we are raising an even number to an exponent of even number, right? And an even exponent. So then ultimately we are going to get an even number, and because the exponent this time, which is D, is also an even number, regardless whether this quantity within the parenthesis is positive or negative, ultimately the result will be a positive even number. Now why I say that? Well, let's take a couple of examples. So suppose we have a negative 2 raised to an even exponent, suppose like this. So this will give us a positive 4. Or if you have a positive 2 raised to an even exponent like this, that also gives us a positive 4. So regardless whether the base is positive or negative, as long as the exponent is an even exponent or even number, then your result will be always an even number, and that will be positive even number. So in this case, our answer is actually that it is going to be a positive even number. That's the correct answer. And if you look at our answer options, we'll see that positive and even, that is actually option H. So option H is the correct option. I hope everything made sense. Thank you for watching. See you in the next video.